Right now, time is moving faster for your head than for your feet. Not by much, just a few nanoseconds per day. But it's real, measurable. Your head is aging faster than your feet. And you've never noticed because the difference is tiny. But it's there, always, every second of your life. And this isn't some quirk of biology. This is gravity, warping time, bending the flow of moments, making the universe fundamentally different at different heights. Carlo Rovelli, one of the most brilliant physicists alive, has spent decades trying to make people understand what this really means. And what he's discovered is shocking. Time is not what you think it is. It's not a river flowing from past to future. It's not a universal clock ticking the same for everyone. Time is a local phenomenon. It moves at different rates in different places, and gravity is the reason why. But here's what nobody tells you. The implications go far beyond physics. They change how we understand reality itself. They reveal that the universe is stranger, more fragmented, more profoundly weird than almost anyone realizes. And once you see it, once you really understand how gravity distorts time, you can never see the world the same way again. Let's start with something simple. You're standing on Earth. Gravity is pulling you down with a force of 1g now. Gravity isn't just pulling your body down. It's also slowing down time. The stronger the gravitational field, the slower time moves. This is called gravitational time dilation. Einstein predicted it in 1915 with his theory of general relativity. And it's been tested thousands of times. It's not controversial. It's not theoretical. It's established fact. But what does it actually mean? It means that if you stand at sea level, time passes slightly slower for you than for someone standing on a mountain. The person on the mountain is farther from Earth's center. There, in a weaker gravitational field. So time moves faster for them, not by much. We're talking about nanoseconds per day. But it's real. Atomic clocks can measure it. Take two identical atomic clocks. Put one at sea level. Put one on top of a tall building. Leave them there for a day. When you compare them, the clock at the top is ahead. It experienced more time. More moments. More ticks forward. The clock at the bottom experienced less time. It lived through fewer moments. Same amount of Earth time. Different amounts of experienced time. Now, Carlo Rovelli asks a question that seems obvious, but is actually profound. Which clock is telling the right time? And the answer is both, and neither. There is no right time. There is no universal clock that defines what now is. Each clock is measuring its own local time. The time at its location in the gravitational field. And both measurements are equally valid. This is the key insight. Time is not absolute, it's relative. Not just relative to motion, which is what special relativity tells us, but relative to gravity, to your position in space, to how close you are to massive objects. Your experience of time depends on where you are, and this isn't just about clocks. This is about you. Your biological processes, your neurons firing, your heart beating, your cells dividing. All of this happens in time. And if time is moving slower for you, then all of these processes are happening slower relative to someone in a weaker gravitational field. You are literally aging slower if you're in a stronger gravitational field. Here's where it gets really strange. This means your feet are aging slower than your head. Your feet are closer to Earth's center. There, in a slightly stronger gravitational field, so time moves slightly slower for them. Your head is farther away. Gefühl. Time moves slightly faster. The difference is absurdly small. Over an entire human lifetime, your head ages maybe 90 billionths of a second more than your feet. You will never notice this, but it's happening right now as you watch this. Your head is experiencing more time than your feet. And Rovelli says this reveals something fundamental about the nature of reality. Time is not a single, unified thing. It's a collection of local flows. Each part of your body is experiencing its own timeline, and they're all slightly different. You are not moving through time as a unified whole. You are a collection of different timelines, loosely synchronized, but fundamentally separate. If you're starting to feel like reality is breaking, good. That means you're paying attention. But before we go deeper, I need you to do something. Subscribe to this channel right now. What I'm about to show you next is going to completely shatter your intuition about time and space. Hit that like button. Share this with someone who thinks they understand how the universe works. Because what's coming will prove they don't. Let's continue. Rovelli explains this with a thought experiment. Imagine two people, one standing at sea level, one standing on a mountain. They both have perfect clocks, and they both watch the same distant star. The star emits light pulses once per second according to the star's own clock. Now, both people count the pulses. How many pulses do they count in what they measure as 1 hour? You'd think they'd both count 3,600. 1 pulse per second, 60 seconds per minute, 60 minutes per hour. But they don't. The person on the mountain counts slightly more pulses, because time is moving faster for them. They experience more seconds in the same interval of star time. The person at sea level counts slightly fewer pulses, because time is moving slower for them. They experience fewer seconds in the same interval, same star, same pulses. Different counts, because time itself is different for each of them. And here's the critical point. There's no objective answer to how many pulses the star emitted in 1 hour. Because there's no objective 1 hour, each observer has their own hour, their own time. And both are correct. This is what Rovelli means when he says time is not fundamental. Time is not a background against which events happen. Time is a relationship between events. It's how we measure change. And that measurement depends on where you are, on how strong the gravitational field is at your location. In a sense, time doesn't exist as an independent thing. What exists is change. And we call the measure of that change time. But the measure changes depending on your perspective. This is deeply unsettling. Because we experience time as universal. We think everyone is experiencing the same now, the same present moment. But we're not. We're each experiencing our own local now. And those nows are not synchronized. They're offset by tiny amounts due to gravity. And by larger amounts if the gravitational differences are larger. Let me give you an extreme example. Black holes. Near a black hole, gravity is so strong that time dilation becomes extreme. If you were to hover just outside the event horizon of a black hole, time would slow down so much that minutes for you could be years, for someone far away. You could watch your spaceship for what feels like 1 hour. But back on your spaceship, decades could pass. Your crew would age, die, and from your perspective, you only waited an hour. This has been depicted in movies. Interstellar got this right. The water planet scene. They land on a planet near a black hole. They spend a few hours there. When they return to the ship, 23 years have passed. This isn't science fiction. This is real physics. Gravitational time dilation. And it shows just how malleable time really is. It's not fixed. It's not universal. It's shaped by mass, by energy, by gravity. And it varies wildly depending on where you are. Now, Rovelli goes further. He asks, if time is relative, if it's different for different observers, then what does it mean to say two events happen at the same time? Einstein already showed that simultaneity is relative to motion. Two events that are simultaneous for one observer are not simultaneous for another observer moving at a different speed, but gravity adds another layer. Two events that are simultaneous for someone at sea level are not simultaneous for someone on a mountain, because time is passing at different rates. So when you say two things happened at the same time, what you really mean is they happened at the same time according to your local clock. But someone else's local clock, in a different gravitational field, would disagree. There is no objective simultaneity. No universal now. The present moment is local, personal, and it doesn't extend across space in a meaningful way. This has profound implications. It means the universe doesn't have a single timeline. There's no cosmic clock ticking away that all events are synchronized to. Instead, the universe is a patchwork of local timelines, all running at slightly different rates, all influencing each other through gravity and motion. And we are embedded in this patchwork. Our timeline is just one thread in an incomprehensibly complex tapestry. We experience time as linear because our local environment is relatively stable. Gravity doesn't change much from moment to moment. So, our local time flows smoothly. But zoom out, look at the universe as a whole, and time becomes fragmented, discontinuous, a mess of overlapping, interacting flows that don't line up neatly. Rovelli also points out something most people never consider. The time dilation we experience on Earth, the difference between sea level and mountain tops, is actually significant on human scales if you accumulate it over a lifetime. GPS satellites orbit at an altitude of about 20,000 kilometers. Up there, gravity is weaker than on Earth's surface, so time moves faster. About 45 microseconds per day faster. That doesn't sound like much. But GPS works by timing radio signals. The signals travel at the speed of light. And light travels about 300 meters per microsecond. So if GPS satellites didn't correct for time dilation, they'd be off by about 13 kilometers per day. Within a week, GPS would be useless. Every time you use GPS to navigate, you're relying on corrections for gravitational time dilation. You're using Einstein's general relativity. You're depending on the fact that time runs at different rates in different places, and it works perfectly, every single time. We're at the halfway point, and what's coming next is going to show you just how deep this goes. But first, you need to make a choice. Are you going to keep learning, or are you going to stay comfortable? Subscribe right now if you want the truth. Hit that like button. Share this video with everyone. Because this isn't just physics. This is reality, and most people have no idea. Let's go deeper. Now, let's talk about what this means for how we understand the universe. Rovelli is one of the founders of loop quantum gravity, a theory that tries to reconcile general relativity with quantum mechanics. And one of the key insights from this work is that time might not exist at the fundamental level. At the quantum scale, the Planck scale, the equations don't have a time variable. They describe relationships between events, but not the passage of time. Time emerges. It's not fundamental. It's something that appears at larger scales, when you have lots of particles interacting, when gravity becomes significant. But at the deepest level, there's no time. There's just change, transitions. Events happening in relation to each other. This is radical. If time is not fundamental, then everything we think we know about cause and effect, about past and future, about the flow of moments, all of it is an approximation. A useful fiction that works at human scales, but breaks down when you dig deeper. Rovelli uses the metaphor of temperature. Temperature feels real. You experience hot and cold. You can measure it. But at the fundamental level, temperature doesn't exist. What exists are particles moving at different speeds. Temperature is an emergent property that describes the average kinetic energy of those particles. It's useful, it's measurable, but it's not fundamental. Time might be the same way. We experience time, we measure it. But at the fundamental level, what exists is change. And time is just our way of describing the relationships between changes. This would explain why time is so weird, why it's relative, why it flows at different rates. Because it's not a thing, it's a description, an emergent pattern that arises from more fundamental processes. Here's another example of gravitational time dilation that you've never thought about. The center of the Earth is in a much stronger gravitational field than the surface. So time moves slower at the center. About 2.5 years slower over the age of the Earth. The Earth is about 4.5 billion years old. But the core of the Earth has only experienced 4,499,997,500 years. The core is 2.5 years younger than the surface, not because it formed later, but because time has been moving slower there. This is how warped time is. Even inside a single planet, different parts have experienced different amounts of time. The universe is not synchronized. It's a collection of local clocks, all running at different rates, all influenced by the distribution of mass and energy. Rovelli also explores the implications for cosmology. When we look at distant galaxies, we're looking at light that has traveled for billions of years. And as that light travels, it's passing through regions of space with different gravitational fields. So the time that light experiences is different from the time we experience. We see galaxies as they were billions of years ago. But what does that mean if time is relative? We say the light took 10 billion years to reach us, but 10 billion years according to whom? According to our clock here on Earth. But the light itself didn't experience time. Photons don't age. They exist in a timeless state. From the photon's perspective, it was emitted and absorbed in the same instant. No chimmy past. So when we talk about the age of the universe, when we say the universe is 13.8 billion years old, we have to ask according to what clock? The answer is according to a hypothetical clock that's been moving freely through space, not influenced by any strong gravitational fields, following the expansion of the universe. That's the reference frame we use. But it's arbitrary. It's not the only valid frame. Every part of the universe has its own local time, and they're all equally real. Now, let's bring this back to something you can relate to, your daily life. You don't notice gravitational time dilation because the effects are tiny, but they're still there. If you spend your life on the ground floor of a building, you age slightly slower than someone who spends their life on the top floor. If you live in a valley, you age slower than someone who lives on a hill. The differences are measured in nanoseconds over a lifetime, but they exist. And this means that your experience of time is unique to you. Nobody else is experiencing exactly the same flow of time. Even people standing right next to you are in slightly different gravitational fields because they're at slightly different heights. Their heads are at different altitudes. Their feet are on slightly different surfaces. Every person is their own local clock. And all these clocks are running at slightly different rates. We're all experiencing our own personal time. And we think we're experiencing the same now, but we're not. We're each in our own now, and those nows are related but not identical. Rovelli says this should change how we think about ourselves and our place in the universe. We think of ourselves as existing in time, moving through time from past to future, but really, we are time. We are the process of change, the flow of moments. And that flow is local to us. It's not universal. We're not passengers on a cosmic train moving through time. We're each our own train, moving at our own rate, influenced by the gravitational landscape around us. And this makes us more autonomous, more independent, but also more isolated. Because we can never truly share the same moment with anyone else. We can be close. We can synchronize our clocks as best we can. But we can never be in the exact same now. Our timelines are parallel but separate. And that's both beautiful and tragic. Let me give you one more extreme example. Neutron stars. These are the collapsed cores of massive stars. They're incredibly dense. A neutron star has about 1.5 times the mass of the Sun compressed into a sphere, only about 20 kilometers across. The gravitational field at the surface is so strong that time dilation is significant. If you could somehow stand on the surface of a neutron star, time would move about 30% slower for you than for someone far away in weak gravity. This means that if you spent what felt like 1 year on the surface, about 1.4 years would pass for someone watching from a distance. This is measurable, observable, and it shows just how much gravity can distort time, and neutron stars aren't even the most extreme case. Black holes are. At the event horizon of a black hole, time dilation becomes infinite. Time stops completely from the perspective of a distant observer. An object falling into a black hole would appear to freeze at the horizon, never quite crossing it. But from the object's perspective, it crosses the horizon and falls to the center in finite time. To completely different stories. Both correct, because time is relative. Rovelli's work also touches on the arrow of time. Why does time seem to flow in one direction? Why do we remember the past but not the future? Why does entropy increase? These are deep questions, and Rovelli argues that the answer is related to our perspective. We experience time as flowing because we're embedded in a universe where entropy is increasing. We're part of a thermodynamic gradient. And our experience of time, our sense of past and future, emerges from that gradient. But at the fundamental level, the laws of physics are time-symmetric. They work the same forward and backward. The arrow of time is not a fundamental feature of the universe. It's an emergent feature that arises from our macroscopic perspective. This means that time's direction is not absolute. It's relative to us, to our position in the universe, to our thermodynamic environment. And in other contexts, in other parts of the universe, time might flow differently, or not flow at all. So what does all of this mean for you for your life? Rovelli would say it means you should stop taking time for granted. Stop thinking of it as a fixed, external thing that you move through. Time is flexible. It's personal. It's shaped by where you are and what you're doing. And recognizing this can change how you relate to your own experience. You're not wasting time. You're experiencing your local flow of moments. And that flow is unique to you. Nobody else will ever experience exactly what you're experiencing. Because nobody else is in exactly the same place, experiencing exactly the same gravitational field, moving at exactly the same speed. Your life is your own timeline. And it's valuable precisely because it's unique. It's unrepeatable. It's your personal journey through the landscape of space-time. And that's something to cherish. Let me close with this. Gravity is not just a force pulling things down. It's a curvature of space-time. It's the shape of the universe, and that shape affects how time flows, makes it speed up in some places, slow down in others, creates a patchwork of different timelines that don't quite line up. And we live in this patchwork. We navigate it, we're shaped by it. Your head and your feet are living in slightly different times. GPS satellites are living in a different time than you. The core of the Earth is living in a different time than the surface. Black holes stop time completely. And through all of this, we persist, we experience, we change. And we call that change time. Carlo Rovelli has spent his career trying to make us see this. Trying to make us understand that time is not what we think. That it's stranger, more beautiful, more profoundly weird than our intuition suggests. And if you've made it this far, if you've stayed with me through all of this, then you're starting to see it too. And once you see it, you can never unsee it. If this video changed how you see time and reality, then you need to do something. Subscribe to this channel immediately. Hit that like button and share this video with everyone who thinks they understand how the universe works, because they none of us do. Closer. And I'm going to keep bringing you the cutting edge of physics, the ideas that challenge everything, the truths that hide in plain sight. So subscribe, share, and I'll see you in the next video, where we'll explore even deeper mysteries of space-time and reality.